Tonight at Klein's Garage, we're going to be CCing the combustion chamber. When you're CCing a combustion chamber, what you're doing is you're checking what the volume of the combustion chamber is. It's extremely important when you're purchasing pistons, custom pistons with a high performance engine, to know exactly what your combustion chamber volume is so you can determine your compression ratio. When you see compression listed for pistons, it may say 10 to 1 compression or 12.5 to 1 compression. 12.5 to 1 means that there's 12.5 times the volume in the cylinder than there is in the head. So if you go in and you do port polishing and clean your ports up and clean your combustion chamber up and de-shroud the valves, if you look at this head closely, you'll see how de-shrouded these valves actually are. They're really opened up. So we took a considerable amount of material out of the combustion chamber. So we do not know exactly what the combustion chamber volume is. This is a B16 head, which is slightly lower compression, approximately 0.2 to 1 lower compression than a GSR cylinder head. Since we took material out, now we increased the volume of the combustion chamber, so we decreased our compression ratio. It makes a huge difference with combustion chamber volume. If you change your combustion chamber volume a small amount, it can change your compression ratio a lot, because it's a small area versus a large area in your cylinder. So what we're going to do is we're going to use this apparatus here I got from Comp Cans. I bought it off Amazon. It cost maybe $60 or something like that. They had it on Prime, so I figured, you know what, I'm going to pick it up. If you've watched my last videos, you saw that I'm in the market for picking up some higher compression custom pistons, roughly 11.5 to 1 compression, that are rated for turbo. And you guys know, if you've done any research on higher compression turbo pistons, they don't make anything aftermarket off the shelf, which honestly I think is ridiculous, because we've come leaps and bounds in tuning technology and such. So anyway, I don't get off track, but with this kit, the first thing you want to do when you're setting this up to do it is you want to make sure that your cylinder head is as level as possible. Now, with headstands, generally the cylinder head's always going to lean to one side. So you got to either stuff some stuff under the legs on it and get it as level as you possibly can. This one's pretty close. It's within the lines. It doesn't have to be exact, but we're pretty square and level enough. So here's a piece of looks like a piece of polycarbonate Lexan, and what this is for is this lays over the combustion chamber and creates a seal to hold the liquid in, because unless it's perfectly level, it's gonna run out of one side or the other side first. And with liquids, unless you're using something with extremely low surface tension, the liquid's always going to cup. If you ever look at a glass from the side that has liquid in it, you always see like a wacky line that's kind of thick, so that the liquid will curl. It's called surface tension. It wants to go to the walls. The capillary action will pull it up onto the walls of the glass. So same thing's going to happen here. You're going to fill this up, and it may go up to maybe possibly even a 30-second plus above the cylinder head before it leaks out, because the surface tension is high and the liquid molecules want to stick together. So what this does is this prevents it from being able to arc over the top with a combustion chamber and throw off your measurement. So what I'm going to do is, I've already dabbed a little bit on here, if you can see it, a little bit of grease. So I just got some wheel bearing grease and just dab it on it real light. All this is going to do is just create a little seal around the combustion chamber, so it's not going to leak out. You don't got to go crazy. It's just a light amount, and then lay it over the chamber. So we got it over the chamber, line our little hole up with this. So what we're going to do is we're going to measure the volume that's currently in our column, I guess you'd call it a column here, to see exactly what it is. So we're going to measure this. If you could kind of see it, we're right around 30 cc's. So we're going to do, got our plate set. I'm going to hold it down, put a little bit of pressure on it. We're going to open this up very slowly to allow our liquid to go in. I'm using, generally use alcohol. I'm using E85 just because that's what I have here. And you just want to let the chamber slowly fill like it is. If you can see, we're filling up. What we do not want to do is overfill it. So when you see it starting to get full, you want to start slowing it down. Another thing that's very important when you're doing this is you got to make sure that your valves are sealed tightly. If you got a bad valve seal, meaning valve to a seat seal, it's going to leak out and run out into one of your ports, and it's going to really throw your measurement off. So, whoop, see, we just filled up there. We're almost full. Going to keep going until we get all this air out. Just about there. Slow it down a little bit. Alright. Right now, our measurement is almost exactly 75. Right about exactly 75 cc's. Feeling our chambers, our ports, I mean. Ports are dry, so we got nothing running out, so we know we didn't have any leakage. We laid a little bit of grease around the outside, so we're not leaking there. So basically do the math. 30 minus about 74.8. So 30 minus 74.8. So we're looking roughly right around 44.8 cc. The OEM B16 cylinder head has a volume of 42.7. So we picked up approximately 2.1 cc's by milling, or I shouldn't say milling, by hand grinding out and deshrouding the valves and cleaning combustion chambers up. So we slightly reduced the compression ratio by doing that. That's more or less the steps on how to check your combustion chamber volume. Thanks for tuning in. As always, guys, have fun and stay safe.